The motors are a custom product we've developed with one of our main suppliers after testing many different motors on the market. Most of the motors are designed to run between 60% and 100% of the rated load. The best efficiency is normally achieved when the motor runs in between these values. This efficient range can vary, of course, from motor design, size, and other factors. Also, all the motors are designed to run for a short term over the rated power, but this can affect the motor longevity. There's a lot of choice around HUB or hub motors, and some are performing really quite well. But the real issue we find is about power output and heat. A small motor needs to be overloaded to be able to output a power required to move an electric longboard. Overload results in a hot motor and a loss of its efficiency. Using an oversized motor results in more power, torque, and less heat because the system doesn't need to work at its maximum potential for the required power. The result of this is a system running much better with no heat problems during long periods of use. There are also some power losses, such as mechanical loss, copper losses, and the winding resistance and iron losses due to the magnetic field to the stator. There are many other factors to consider in the construction of a motor. I mean, we could talk for hours about it, but this is just about giving you some basic information and background to our design. Here are some examples to compare. These are all motors that pretty much have a decent amount of power, but after some time in use, they start to run too hot and they lose their efficiency. The goal is to find a good balance between the compact size required for an electric skateboard and enough power. We used a long stator motor and considered the occasionally high demand during hard acceleration and hill climbing. In addition, we included into the motor design a fan to help it cool down. Load, power, and current measurements have all been measured during the testing. Our battery, it's a 9Ah capacity, so the range is over 40 kilometers. We've made sure that the whole system runs cool for the whole battery cycle. Let's do some comparisons with some of the other motors that are on the market. This is the first one, and you can see here the wheels, it's quite well made. The main problem, the challenge for these guys is the way the wiring comes out, as we've talked about before. Inside here, it's very, very fragile. And of course, this is only 50 millimeters in diameter and 30 millimeters in width, which means it's going to be very inefficient. It's going to get hot very, very quickly and lose efficiency. And that's the main problem with this one. This is the second one. The quality of construction is actually worse than the first one. The wheel itself, if the wheel becomes damaged, you can't actually take this off, so you'd have to replace the whole of this wheel unit. If we look at the motor itself, it's going to be more efficient because it's 50 in its diameter and 35 in its width. So it's a slightly more efficient, but it's not been as well made actually as the first one. And although there's some good things about it, overall, again, it's not a very well constructed motor. This is the third model. This motor is actually better made. You can see that by the windings on the inside here, and you can also see by the arrangements of the magnets inside the wheel housing. So it's a better constructed motor. They've also increased the power by making it wider. You can see here it's actually 40. But what they've done is, unfortunately, they've sacrificed on the diameter, and they've shrunk that down to a 45 millimeter diameter. So although it's a powerful motor and it's quite well made, it's still inefficient, and it's going to heat up, which is going to lead to a loss of power and a loss of efficiency in the long run. Finally, we're coming on to our pride and joy. You can see the difference immediately right from the start. You can see with this, the titanium axle here, the craftsmanship on it, the ceramic bearings, you can see here, the oversized copper wiring on the inside here, and of course the size. So it's 40 mil in width and 55 mil in diameter. So this is giving us an incredible amount of power. But the way it's been put together and what it enables us to do is it enables us to have the power, have the efficiency without loss of energy in any way. And because of the fan that's blowing air through it, it's going to be staying cool for the whole journey. So it's not going to depreciate in any way. The power that this gives out is going to stay the same through your whole journey. You can see what we've produced already is pioneering work. We're keen on not only meeting expectations, but exceeding expectations. And that's why we're happy and excited to share with you the beast. This is an enormous motor. The power that it's going to generate is incredible. It's 55 millimeters wide and 55 millimeters in diameter. This produces an incredible amount of power, and it's what's going to lead the way in our 6384 motors as we look to the future. It's going to mean that anybody who wants to get on a motorized skateboard is going to be able to get on a motorized skateboard and experience the power and the thrill of a ride that it can produce.